This is Unit 3, Worksheet 3, question number 5. The question states, suppose a bag full of ice, 450 grams, at 0.00 degrees Celsius sits on the counter and begins to melt to liquid water. How much energy must be absorbed by the ice if 2/3 of it melted? Very first thing we should do, draw a heating or cooling curve. So we need to identify if it's going to be heating or cooling. So suppose a bag full of ice at 0 degrees Celsius sits on the counter and begins to melt. Oh, so melt. This is probably going to be a heating curve because we only see melting on our heating curve. How much energy must be absorbed? Oh, absorbed. That's going to be another key word for a heating curve. E plus, energy being added or absorbed by the system, is very indicative of a heating curve. Now, because we know this is going to be melting, at 0 degrees Celsius, I'm just going to be a flat line when we're going from solid to liquid, and that's occurring at 0 degrees Celsius. This is a heating curve. Next, I'm going to be setting up my table. So, Q, my mass, my change in temperature, and then finally, if it's going to be heat capacity, my heat of fusion, or my heat of vaporization. So, for this problem, energy. Let's see, how much energy... Oh, how much energy must be absorbed? We're looking for that. So, question mark, and it should be in joules. Now, I'm told that I have, suppose, a bag full of ice. Oh, 450 grams. Okay, so we have that down. What else? Oh, my change in temperature? Well, hey, it looks like it's a flat line. My temperature is not changing. So I can cross that out. Ooh, that means I can also cross out my C, because that involves a temperature change. Now, heat of fusion. That involves the keywords melting or freezing. Oh, I see melting right up here. Melting. So I should use melting, and this is for water. So that means it's going to be 334 joules are required to melt 1 gram. I can definitely cross off my heat of vaporization there. Hey, so I have my 4 variables filled in. The one I don't know, and then the 3 that I do. So what I can do, I can set up my ladder at this point. So I'm going to set up my ladder down here. And I'm going to be using either 334 joules over 1 gram, or 1 gram over 334 joules. Wow, I'm looking for my joules. So I'm going to be using the fraction that has joules up on top. So 334 joules are required to melt 1 gram. And I actually have 450 grams. I only have one of those. That's going to cancel out my grams. And when I multiply these together, I'm just going to have my units in joules. So 334 times 450, that's going to give me my value at this point with 150,300 joules. That's the amount of energy required to completely melt 450 grams. Should be done. Oh wait, how much energy must be absorbed if 2/3 of it has melted? Oh, that's a shame. So, there's a couple ways I can do this. I can either say, hey, to get to this point, it's going to be about 2/3 on our graph. So, 2/3 over here, 1/3 over. So, I should just be able to take this answer at the end and multiply it by 1/3. Actually, it's probably 2/3 because it takes 2/3 to get to that point melting. So, if I multiply that by 2/3, the answer I'm going to end up with is 100,200 joules to melt 2/3 of 450 grams. So this is definitely one way where we can represent it, what we're looking for. Another way where we can do that is, instead of multiplying the 2/3 by the end, what we can actually end up doing is just say, instead of our mass being a total of 450 grams, we can multiply that by 2/3. And then that should give us 300 grams. And then we would just use that number instead. for our table. It would be the exact same setup for our ladder, where we have our 334 joules are required to melt 1 gram of the substance, but instead of multiplying by 450, we multiply by just 300. And we only have one of that still. Units still cancel out, and then when we multiply through, we're going to end up with 100,200 joules. That's the same number we ended up with over here, but instead of multiplying by 2/3 at the end, we multiply by 2/3 early. Either one of these is acceptable. So I'm just going to rewrite that. So that's 100,200 joules of energy to melt 300 grams of ice, which is 2/3 of a bag, where the bag is 450 grams. So either approach is acceptable, where you can do the 2/3 of your final answer or your 2/3 of your mass before plugging that in.